AI support agents can significantly improve customer communication for companies. However, they can also cause major issues. When they lack answers to customer questions, they may hallucinate, generating incorrect responses and suggesting non-existent products and discounts. In this presentation, Coach Cindy, an engineering leader with extensive experience in machine learning, introduces Retrieval Augmented Generation, a technology that reduces AI hallucination by enabling AI support agents to access up-to-date information. Don't forget to subscribe to our channel for the latest updates and insights on AI advancements and learning opportunities.
Tonight's topic is about from fantasy to facts. So this explains that when we're using large language model for personal uses, then you could have like some errors that it does not really matter. But sometimes when you're using it for enterprise level, then when you're servicing your customer through large language model, then if your answer would be it's low confidence or it's wrong, then it really matters. So today we're talking about a situation that we want to solve. And the mechanism to solve it is called Retrieval Augmented Generation, or abbreviated as RAG. Based on the audience today will be a combination of English-speaking person and Chinese-speaking person. So for certain important aspects or terminology, I might repeat in Chinese so that people can proceed without any language barriers. So let's talk about this. Is a story that is written by large language model. So it's saying that here in this mysterious land of Eldoria, in this forest, and there is a prophecy saying the rising of a hero will be able to restore the lost crystal of eternity. And this dragon, and with all the shimmering scales, and he is circling this peak of this mountain, and he has this sword, and then he is journeying through the enchanted glens and battling shadowly with. And on the right side, it is a picture that is being generated by AI regarding this story. 所以这个故事呢，讲的是在这块神秘的土地上，然后这个神秘的森林里，然后有一个英雄，然后要去寻找那个永恒的钻石，然后这个龙身上有着闪闪发光的鳞片来帮这个英雄，然后一起与那些阴影中的灵魂这个灵魂战斗。So this is a fantasy story. And in the fantasy story, it created like a fictional place and a fictional story, and then generate a fictional animal and a fictional encounter of the hero of the story with a dragon. So and then after me and my large language model in this situation, ChatGPT, having this encounter, I asked him a question. I said, I work for this company, Eldoria. Okay, this is the land of Eldoria that you mentioned just now. I said, I work for this company, Eldoria, and my job is to collect wraith. And my job is to hunt for ghosts and collect them. May I work remotely from Paris? So this is may I work remotely from Paris is a very realistic question that a regular employee in a regular company might ask. But given the fictional background of the Eldoria as the mysterious land, and the job is to collect the ghost, then I'm really curious what ChatGPT is going to tell me. So after thinking, then ChatGPT said, well, it depends on, your job responsibility, depending on your company's policy, depending on does that have any legal or logistical considerations, and how do you communicate with your management, and how do you collaborate with your coworkers, et cetera, et cetera. So clearly that ChatGPT was able to understand that, working remotely from Paris is the essential request of my question. but he's not able to recognize that the land of Edoria and hunting ghost is not exactly a traditional lab situation of a job. So he did mention that in this case, presumably it's in a fictional land of Edoria. The remote work might be challenging. So although it's recognizing context of the fictional part of it, the way that it's answering it is still like, really missing the point, does not having the understanding of the humorous part of the question or able to answer it in a fictional way. So in other words, that ChatGPT really making up all these job responsibilities and company policies and legal considerations, etc., as part of what he understands a general question should be answered in this context. And this is what we call hallucination. So when things do not really exist, then our large language models in this situation, ChatGPT, and in other situations, it could be other, could be the Meta Lemma, could be the Anthropic Claude, it could be DeepSeek or other models will be able to answer questions in a very similar way, aka creating things that does not exist in the real world, right? So let's look at how hallucinations happen. Hallucination has been existing in ChatGPT probably since the day it was launched back in 2022. And while with all the significant efforts try to fix the problem, it still exists more or less. And then, there are many reasons, many things that we have already done, try to fix the problem. But then there are still, it's still happening a lot. So one reason is called domain shift. The reason is that when a large language model is being trained, it is using the data that exists in the real world. It has like all the data that human beings have created in many, many years of our civilization, has all the books that we have published. It has all the subtitles of the TV and movie that we have produced. It has a natural conversation of the Reddit threads that human beings have been talking, and they have some of the area of the email information or live chat information that we're able to legally have our access to. Then with all this training information, as a large language model, it does not really have a way to tell that which part of the data that is being trained on is more credible than other pieces of the data. 所以呢，它就很难断定什么地方的数据更值得被信任。In such a situation that, when it's being trained with conflicting data or data of different importance, then it does not really distinguish which data is more reliable than others. So therefore, when you're asking questions, then it does not really tell you the right answer. An easy example would be like if you ask that when will be a lowest age that I'm able to get a driver's license, or when is the legal age that I'm able to get married. Then because like different country and different state have different answers, then the answer from these models will probably be very vague. So that's one situation. So what we saw just now is a situation of the domain shift, as in when the ChatGPT knows about this fictional land of Eldoria, and then we're telling him that, well, I indeed interested in can I work remotely from Paris information, then it's really not able to tell that Eldoria is a place that I'm able to work, or it is not a place that a regular work will be conducted. The second reason that hallucinations happen is called task shift, as in okay, as a model, I already been trained on this data and I'm ready to answer certain questions. But then when you're asking me to answer certain questions, such as AKA perform certain tasks, and then I'm not sure that exactly what you want me to do. And because I kind of assumed that you might want me to do certain things, then the results might be not necessarily what you were looking for. So a couple of years ago, when Google released their PALM large language model, PALM, and then they have a situation that it went kind of become pretty famous. People asking that, tell me about the elephant on the moon. So the large language model answered, well, the elephant on the moon, her name is Luna, and she is pink. She's very cute, and keep going and tell a whole story about the elephant Luna living on the moon and what her life is like. That's why I created this picture from ChatGPT. Really, really cute little pink elephant. So the reason is that when you're asking in a scientific manner, as in tell me about the elephant on the moon, you are kind of expecting the model to be able to research the scientific fact first, as in kind of on the moon there is no elephant living there, no water, no air, etc. But then if the model might be thinking or assuming that you are asking a question about the children's bedtime story. So if it's a 5-year-old asking her mother, as in, Mom, tell me about the elephant on the moon. And then if the mother answered that, there is an elephant named Luna and she's pink, it might be a perfect answer. So this is a second scenario of how hallucinations happen, as in when you're having a task that in the person's mind, but not necessarily conveyed in a clarity that can be understood by the large language model. It might understand the task as some other things, and then answer it accordingly, as giving you an answer that you do not expect. The third situation is about the data restrictions. So just now we mentioned that large language models are being trained by the data that we have access to. But then there are still tons of private data that people do not have access to. For example, JP Morgan is a company that have about hundreds of years of customer data. So when you're asking a general large language model who does not have access to the private data, you're asking that, hey, tell me about what kind of customers would have a higher risk to default in a loan, then the general foundation model might give you an answer that does not necessarily have a very precise answering. Whereas if hypothetically, if JP Morgan has trained a separate private model with the data that they have access to, they might give you a very good answer regarding what kind of customer would have a higher rate of default on their loans. So that's 3 reasons how hallucinations might happen. Now let's talk about well, is there a way that we can harness the large language model so that it's answering things when it is sure about what it's talking about, and when it does not know what the domain or the task, then just say that you do not know, so that you can get the trust in the enterprise usage. In other words, that there was a probabilistic answer, and then let's change it, go all the way to deterministic answer， 就是把这个回答大模型的回答从概率化的回答变成确定性的回答，这是非常重要的一个概念。Okay, so let's talk about suppose there is an enterprise, you have millions of customers exchanging millions of emails on a daily basis, kind of conducting millions of transactions on a daily basis, and then submit certain requests and need customer support every day. Then what do these enterprise requirements that have in common? The first thing is that the answer that an enterprise is looking for has to be accurate. Every company have their internal rules and policies. If you're asking that, hey, can I return this thing? It is a yes or no answer according to the return policy, right? So you want to be able to answer that correctly. Like, how much refund am I going to get? It is not a excuse me. It's not a probabilistic answer as a lot of large language models give. Well, you're going to get a refund for $37.94. It's a very precise number that you want to be sure, right? And then also there is security, as in, every enterprise has their certain customer data or private customer activity data that they want to protect. For example, Facebook, Meta as a company, right? They have 8 billion customers, but then the customer interaction data, that their customer posted their information online, which becomes public, but their customer interaction data and customer historical data are private data that they want to protect. So every company has certain data that they want to protect, and it probably also becomes a very important equity of this company and does not want to share with any other people. Right. The third thing is about an enterprise company needs to be reliable. So the results, if I tell you that you can return this item, and then the results need to be repetitive. If you ask another customer, a support representative, if I tell you that I'm going to refund you $23, and then if you ask another support representative, you're going to be refunded exactly the same thing. The results needs to be repetitive. And then it's also things needs to be cost reasonable. So you can say that, hey, why don't you just retrain your model with all your private data and private transactions on a daily basis, and then your model will always get the best results. Does not necessarily work that way, because that it's extremely expensive to train the model. There are hundreds of millions costs to build a cluster that are able to train a large language model, and sometimes it's the model would take many months to train, and or at least many weeks. So you cannot get a fast enough training so that you can be reasonable with the answer that you're going to provide today based on the data that you collected today, right? So let's talk about then how do we handle this situation? The architecture handling this is called Retrieval Augmented Generation. It is a paper. I put the link here. If you have further interest, feel free to read the paper. So this is an idea that was proposed in 2021. And the idea basically saying that this is called the response query and context triangle. So when a person or when a customer is asking something, asking the model something, that is a query. And then we are going to say that, hey, is the retrieved context. So there will be certain things that we build into the model architecture. We build into the system as a context, which we're going to talk about mainly later. And so we're going to ask that, well, is there for what you're asking, is this related to the context that you have? And then based on the context, we're going to say that, well, is the response that you're going to generate being supported by the context? And so this is called groundedness. So only when your response is able to be grounded in the context, then I'm going to reply a related answer to your query. And keep going for the next query iteration, etc. So you can see that this architecture changes the large language model from you ask me something, I'll respond with whatever that I have, right? Change from that architecture with an additional important piece called the context, as in you want to make sure that if you're asking things related to the context, aka this company's business, if you're asking me things that are not related to my business, fine. I do not have that much restrictions about how I answer. But if you're asking anything regarding to the business that I'm having, and then I want to make sure that everything I answer are grounded. And then build this groundedness into the responses that I'm going to provide it back to the customer. And then, so, well, the next question is, oh, sounds great idea. Then how do we build it, right? So let's look at this reg pipeline. So you have a bunch of documents. These documents can be considered as the company's proprietary documents. They're private data. These documents can be their internal policy, such as their return policy, can be their internal company policy, such as what your HR document or your code of conduct for the employees, right? It can be certain information that about the purchase return rate that you do not necessarily want to share with other people. It can be the document of the past transactions or the the historical data of this such a customer, etc. So all these private documents that you have, you want to split the doc instead of training the model again with your private data. You want to split the document into chunks, which we'll explain later, but for now you can understand the chunks as small pieces of the document. 就是在这个地方呢，就是把这个文件切分成比较小的小块。And then you need to turn these chunks into embeddings. Embedding is an idea that is commonly used in machine learning. Basically, a machine learning model does not have the understanding of the documents as in the human language or pictures or audio or video. A machine learning model does not understand all that. Everything needs to be converted into float numbers that can be understood by the model, which is called embeddings. There are many ways to generate embeddings, but that's beyond the conversation today. So you have these documents, you process it in a way so that the models are able to understand. You put it in a database, and then you index the database. So this is called an ingestion pipeline. So this is like, remember here that when you're creating this context, and then you need to ingest, you can ingest the company information into this ingestion pipeline. And then there is a retrieval process. So here is that when you're creating responses, then you're going to generate from the contexts that are already being created. That's your retrieval process. Then you have a query, and then you look in this indexed database. You find out your best results called top K, which we're going to talk about the top K later. And then with all this information that you're getting, you give it to a large language model saying that this is the context that you're having, and this is the original query that are being asked. Based on these two pieces of information, generate a response to me. So here in the RAG pipeline, we're seeing a few things that we're going to talk about, one piece and another in our later presentations. Number one is that you're going to get your original documentation, you're going to split it. Number two is that you're going to convert it to numbers. Number three is that you're going to store it in the database for effective search. And the number four is that you're going to combine the context with the original query to generate a response. So that's how a RAG pipeline works. Okay, let's talk about the documentation representation in a vector space. So when you have a data, you split it into many pieces. Well, the first thing is why? Why don't you just have one piece and then put it in a vector database and that would be it? Why do you even bother? The reason is for your search is that when you are searching for things, if you get the entire document, you get a lot of noise about how do you answer. So think about that when you're interacting with a large language model, you're asking for a particular question, you're expecting a question, an answer about what you ask for, right? If the model just saying, here is a 700-page document, go read, the answer you're looking for is within this document. It is not very helpful, right? So in that situation, that's the reason that we are really chunking different things, so that you're only retrieving the most relevant piece of the information, and then we'll only use this to answer the questions. Now it comes to a situation, well, how many pieces shall I chunk it? How many pieces? I have a 700-page document. Shall I chunk it to 700 different chunks, or 1,400, or 35? What is my magic number? Right. Well, the quick answer is that it depends. It depends on a few trade-offs, which we'll talk about later as well. But currently you can understand as in, if you split it into too many chunks, then the retrieval process will be slow. So if you have a document of 700 pages, probably altogether have, 1 million words, right? And then if you split into, why don't I have like one word as one chunk? Then in that situation, you have every time that you search for something, you need to search from 1 million items. So that would slow down your search. But it also have another problem, as in when you're splitting things too much, then each word does not really tell you what's in the document anymore. So when you split things by sentence, you kind of know what this sentence is talking about. But if you're like splitting by by phrases, then you do not really understand exactly what this document is talking about. You do understand what this phrase or this word is talking about, but because all the documents are composed of words, then the result of splitting this document and splitting another 500-page document would not be different at all. You get all those words that are individually not dependent on each other and do not provide context against each other. So that's one direction to the extreme. The other direction is, as what we said, is that, I do not split at all. And then I just provide you with the entire document. And then you can, I know that what you're looking for is within this document. And how about you figure out yourself, right? That is not very good customer service either. So we want to pick a number that is kind of makes sense. So let's look at two examples about chunking. This is Abraham Lincoln's Gettysburg Address. It's a very short speech, so we're able to split it in different ways. Let's look at the left side first. So you can see that it looks like the letters or tokens in the machine learning domain. The tokens that in the first chunk is is the same as the second chunk, and it is the same as the third chunk. So basically, we pre-select a number, a magic number that we like. For example, that I want, say, 20 tokens in a sentence, and then this is a document that I'm going to split it this way. Chunk 1, chunk 2, chunk 3, and then if you're asking me that. A question, that I'm going to pull out a chunk that are related to what you're asking me and then be able to answer it. What problem with this way of splitting? Well, so first you're going to split in the middle of the sentence so that you understand that 87 years ago our forefathers founded on this continent a new nation. And what is this new nation about? This chunk does not provide you with. So, which means that you're getting cut off information. And then you need to try to find the second piece that would be more related to this topic about this new nation. It could be number 2, or it could be something else. So you kind of suffer this problem of like incomplete sentences. So that's one problem. The other problem is that let's look at piece number 1 and piece number 2. It does not have anything in overlap, which means that in a vector database, which we're going to talk about the mechanisms a little later. But when we store it in a database, the first chunk and second chunk really does not have anything to do with each other. So they might be stored in different places because they don't have anything to do with each other. So retrieval of the first piece does not necessarily make it more likely to retrieve the second piece. So this is, the challenges about chunking your documentation in the first way. Then let's look at the second way. So as you can see that for this situation, the chunk, the letters or the tokens included in each chunk is a little more than just now, but that was not exactly the point. The real difference is that you can see that chunk 1, this blue box, and chunk 2, this red box, and chunk 3, this orange box, have a decent size of overlap. Meaning that the information in chunk 1 will be related to what the information in chunk 2, which will be related to information in chunk 3. Which also will mean that when you store this A in a vector database, because 1 and 2 are related somehow, therefore 2 will be stored closer to 1 than this situation. And the same going forward. So this is a more acceptable or more pragmatic way of chunking, is that number one, you try to collect information as much as possible. You have a window, collect information about the original document as much as possible. Number two, you have certain overlap in a way so that the incomplete sentence in section 1 will be presented or completed in section 2 because it's adjacent chunk. Number three, the third situation is that because they overlap, then they're going to be stored closer in a vector database. So these are a few considerations about chunking. So meaning this is a correct way of doing it. The left side is a correct way of doing it. The right side way is a correct one doing it. Right side is probably a more popular usage and probably will also provide you with better search results. And then just now we talk about embedding. So let's go back to this. So first you have the documentation, you split the documentation into chunks, and then you need to encode your different chunks into embeddings, which are float numbers. And then next thing we'll talk about will be the embeddings. Embedding is a little scary word if you have never worked with machine learning in the past. But what it's really doing is do a transformation. So you start with a sentence or a phrase or a token, and then you do certain transformations, and then you provide code here. Is indeed the results of the embedding will be a vector of the float numbers. And then you're going you're going to use this float numbers vector for calculation, and then when you're done, you should be able to decode the entire thing to this to the original output. So you can understand the idea of creating embeddings as in creating the zip file. Like when you used to compressing the file, 就是这个 embedding 就有点像我们压缩文件。So you start with original, and then you start with like compressing or starting with compressing the original file. It's called encoder. And through a process that you're going to generate certain things, which is intermediate results that as a human being, you really do not care. And then a model is going to use this intermediate zipped information for calculation. And then when the calculation is done, we return you certain things, and then you are like depressing your zip file, decompressing your zip file, and with a decoder and into its original format. So this is an example of an encoding process. So first, you have a text, says certain things, right? What it says does not matter. How long it is does not matter. Runs it through an embedding model, and then it will be generated into a vector. Keep in mind, this vector is a float number. It could be 1,000 dimensions of the float number or 10,000 dimensions of the float number, depending on how your embedding model is being defined. And then, the large language model is going to use this for calculation. After it's done, a reverse process, if you just reverse its arrows, going through the same embedding model but from a different direction, and then would give you back the original text from it. In a multi-model situation, when we're talking about multi-model, 叫多模态 multi-model 是多模态。When we're talking about multi-model, it is that you can have text, you can have images, you can have audio, sound, or you can have video. Everything can be encoded by this embedding model. It will be a different embedding model for different kind of things, or it can be one embedding model that can encode everything. Does not matter. But the idea is that you start with certain things that you want to process, and you're going to end up with a vector that machine learning model can understand. And then when machine learning model is done, then it will be returned to its original format. So let's go back to this section again. So we get the embeddings, and then embeddings are going to be stored in a database. This database is called vector database. Let's look at this vector database. Vector database, so you can see that, here is a vectors. This is a database, have all the vectors. These are the vector of float numbers. Keep in mind, these are vectors of float numbers. And then these are your original data kind of mapping to all these float numbers. And you are like, well, since your original data is here, then why do you even need it here, right? You can just search these data here in the blue box, and then when you get what you need, you just convert it to the vector. Isn't that enough? Good idea. Except that the searching mechanism on the vector database is different. So just now we talk about indexing, as in like when you're putting data in a vector database, they will be stored as vectors. In a vector database, when you do search, it does not search on the original data, because searching on the original data is not only slow but also not precise. Instead, we search on these vectors directly. Keep in mind, these are float numbers. Machine learning and all the retrieval, your documentation process would process the numbers like very, very fast. And then, so you're going to index the data in your database with the vectors itself. So the data is just links to the vectors. When you decide to retrieve all these three vectors, and then you try to get the data out it, instead of you search on the data, which will give you like slow and not correct answers. So that's very important between like I know that a lot of people have the understanding of a relational database, which, your data are stored in rows and columns, in a NoSQL database that your data is being stored in key value pairs. And then we already know that the NoSQL database probably is more high performance for searching, because you can search for case. You do not necessarily have to search for values, right? So consider this vector database as a little bit like, these vectors are the case that you're searching for, except that your case that in a traditional NoSQL database is very likely are still strings that searching is by exact matching. And then but here, if we search by vectors, then we're able to do the semantic search that, is the idea that people are talking about. So this is the indexing process. And in vector database, first you do the indexing, is put your data in, and then you do the search, and then you process your search result with re-ranking. So indexing. Let's talk about how indexings work. So you have a document to start with, and then you split your document into different chunks like this, right? And then different chunks will be converted to the vectors and stored in this area. And then your document data will be stored in this blue area. So note that the left side document chunks and the right side document chunks are exactly the same thing. So when you're ingesting the data into a vector DB, you really have the same data is being used for indexing and the same data are being used for retrieval. Keep that in mind. Of course, there are many levels, and because a vector DB is a database as well, there are many ways to handle the scalability issues that any database would need to handle. And this is an example about, when you have a really large document, then you split them into several parent documents, which will be split into many more child documents. And then child documents will be corresponding to each chunks. And then, how do we do the indexing and the retrieval process? This is to handle scalability issues, but the concept and idea about how a vector database works still the same. Note that I'm only giving 2 examples now. There are like a lot more other ways to optimize a vector database, just like, any other commercial database product would have many, many ways to optimize for scalability. So then let's look at great, I get everything that into my vector database and I want to do a search. How do I do it? I want to look for things. Well, keep in mind that the things are being stored in a vector. So let's go back to this. So when you're seeing that a document split into chunks and chunks are being placed in different vectors, right? And then every vector will have its own vector space. So this is a simplified version that you simplify the vector in a 3D space, and then you can see that the vectors are like this way. And this is another example that, here is your original point, and then your data are being, stored in all these places. Consider every one of them as a vector that, from your original point to here. So in order to leverage the convenience created by the vector search in float number groups. And then let's consider that, your different vectors are in a multi-dimensional space. We just use this to help with understanding visualization, but does not consider that the vectors are only 3D vectors. It can very likely to be 1,000 dimensions or 4,000 dimensions or 10,000 dimensions, right? But the calculation of vectors are still the same, obey all the, your college vector calculation rules. So when I have a query, I'm going to convert the query that I have into float numbers as well. And my float number will be represented by this green button here, this green bubble here. So I'm going to query something that should be answering my query question represented by the green bubble. And what it does is that it's going to get the k nearest neighbor. So there are many different algorithms being used. K nearest neighbor is one. Approximate nearest neighbor is one. This is, I think, a local some cache. Sorry, don't remember. I think. I don't remember what LSH stands for. So this is some hashing.
Locality sensitive hashing.
Yes, sensitivity hashing. This hashing algorithm is one. But the general idea is about, thank you, Dr. Lin. The general idea is about that, you have a green button. You want to find out a few closest bubbles or closest vectors in a space. to this green button. So this is a document chunk. This is another document chunk. This is another document chunk. And in a multi-dimensional space and with certain rules of calculation, the vector have the distance can be calculated mathematically. It's not guessing, it's mathematical results, right? When I find out that these are the closest chunks closest to me, I'm going to retrieve these blue bubbles because I believe that they are going to get the answer that I'm looking for. So this is a search. Well, and then the next question is like, why? Why do I want 4 blue bubbles instead of 40? Why I want 4 instead of 400, right? If I just retrieve everything, say for 400 bubbles, wouldn't I get like better answers? Well, let's see. So this is called search re-ranking, which is about that your query is going to get some results, and then you're going to get try to understand your results in a certain way. So your query is getting, you query something here. You have a green bubble here, right? You're going to get a few bubbles that are closest to you, and then you have 4 bubbles out. And not all of them are your best answers. So, and then it's like, why do I want 4? Well, of course, you can get 40 with no problem. It's just like to process 40, then you need more calculation. So this is a second point of the trade-off point, as in like, does retrieving more search candidate, these are how many is called search candidate, does retrieving more search candidate will be a better, will help you to improve your answers? Well, the short answer is that I don't know. You need to calculate according to exactly what your system wants and what your system needs, and then get from it. But first, you get those 4 bubbles that you want, and then you rearrange them according to certain rules called re-rank. Normally, these days, re-rank is being done by another model as well. But for simplicity purposes, let's just say that let's re-rank by how deep the color is. Re-rank in certain ways. And these are the re-rank results that you're going to use to generate an answer from. Suppose your answer is here. So this step is called candidate generation. This step is called re-ranking. Then the purpose of re-ranking is make sure the most relevant result is on the very top of it. And then you can do a cutoff, as in like, I only want the first one to generate my answer. There you go. For example, if your question is that, give me the address for Washington University, and University of Washington, and then it's going to tell you that, it's one answer would be enough. The most relevant answer should be enough, giving you 1, 2, 3 on ABC Street with a zip code 56789. That is the correct answer. That's great. One answer can one chunk of the documentation can provide you with a perfect answer. There will be situations that you need multiple points to get a good answer, right? Like, give me the restaurant near me that are still open at this hour and serve Japanese food. Then you're going to get a lot of restaurants, and then you're going to do the re-ranking, as in which one's nearest to me, and they fulfill the condition that you want. And they do want to provide a list of answers. You do not want to just provide one restaurant. You want to provide multiple restaurants for the customer to choose from. So in other words, how search generates candidates and how re-rank decide on how many candidates to get, it's really depending on exactly what you're trying to do. it may not necessarily that you retune your re-ranking mechanism by every different query. That is not right, because I said that normally re-ranking is generated by language models, but it's really re-ranking is defined by the business that you're running. What information that you're trying to provide. Okay, so we talk about the vector database, how to ingest data into it. We talk about that after you get data into the vector database, how do you do the search? And then we also talk about that in order to provide the most valuable results to search, then how do you do the re-ranking? Now let's go back to look at the entire reg query process. So you started with the document collection, which is your private data, enterprise private data. And then you have a search query or a question that, is what you're trying to satisfy. With both pieces, you do the encoder and you use the same embedding model to translate all this into float numbers. Float numbers are stored in the vector database here. And then you're going to search your vector database. You generate a list of the search candidates, and then you do a re-ranking mechanism and decide on what answers that you're going to provide. And then you use this same embedding model only to decode the float numbers into original text. And then you have a ranked list to provide, to generate the answers for your customers. So that's how a reg query works. Now, well, we talk about it, we talk about hallucination. We're saying that, large language models are not very reliable. And then we're saying that here is this wonderful reg system that are able to provide very reliable answers, because for every question that you ask is going to ground the answers against the context that you're given, which is your enterprise documentation that you have over there, and then it should provide really good answers, right? Well, it does have reg also have challenges as well. Just like any software systems, it is a software system. It needs to be built in a reasonable way. Hypothetically, it's working, but pragmatically, there are a lot of tune-ups, a lot of additional work that needs to get done. One challenge is that it has is called mismatch, as in I want to search for certain things, I did not get it. For example, I want to search for the restaurants that are open at this hour, and then I'm able to I get like a spa open at this hour. I did not get a restaurant out. Why? It could be many reasons attributing to it. One reason can be that I do not have enough documents regarding the restaurants. For example, that my documentation tells me that there are open gym nearby, there are open spa nearby, there is open grocery store nearby, but the restaurants are labeled as grocery store instead of as restaurant itself, because for whatever reason that my data considered restaurant is part of grocery store. Then when I'm searching for this, I'm going to get like irrelevant information, right? So mismatch of your result is very likely is a data problem, is that your data is not doing great, or your data is you do not have complete data, or your data is wrong or whatsoever. And then second kind of problem is coverage problem. As in, I know there is a restaurant, 2 blocks away from me, and I know that restaurant is open, but when you return the results to me, it did not include that restaurant. So there are certain feedbacks that I'm able to give this reg system, saying, hey, you're not having the right coverage. You do not have the information that I know that you already have. Then, so just now we said that mismatch is very likely to be a data issue, whereas the coverage, aka returning an incomplete list, is very likely to be a search issue. As in, you're not generating the right candidates from the search, or during your re-ranking process, the relevant candidate is just ranked as like low relevance, so that you do not really display it. So that's where you should look at. So if then you need to do a little debug, as in like, hey, I know that I should return 5 restaurants. Are you returning all the 5 restaurants? If you are not returning all 5, you only return 3. Then we know that your search has not generated enough candidate. Then you need to tune up your search parameters a little bit to generate more candidates. But there could be situations that I know there are 5 restaurants should come up with this search, and then I do get 5 restaurants, but when you display the information to me and you just say that here are 2 restaurants you can go to, then that's your re-ranking problem. Then tune up your re-ranking setup, right? The third thing is about bias and fairness. So when we are talking about bias and fairness, very likely, very often, I would say that if you're not dealing with the data management a lot, it's very likely that you come to a situation that you always think bias from a social perspective. Do we have the right racial group? Do we have equal opportunities for all? Whereas the bias and fairness in a machine learning context is really about the data bias and data fairness, aka as in sometimes there are more dominant data points that are just like occurred more, and then you need to understand what that means. For example, when we're talking about inflation, right now when we're talking about inflation, everyone know, egg prices raise. Why? Because number one, yes, egg prices is higher. Number two, it's in the news all the time. So when you're doing the document analysis, that egg prices would dominate what your large language models input, as in like a lot of inflation talk about egg prices raises. But then, the gas prices have decreased. So, but, it does not make as much news. So people do not pay attention to it. And the same thing, when people talk about the gas prices, the energy prices, right? People talk about the gas prices all the time. People do not talk about the natural gas. So when especially that in the context of energy, gas is one word, natural gas are 2 words. So when you're to do the analysis at like the word level, then very likely you're going to group some of the natural gas information as a gas information. So that would make things wrong as well, as in like you understand natural gas as part of gas, which is not true in a pragmatic way. So and also like when you're talking about natural gas, and then you're talking about Russia exports natural gas, which probably dominant news cycle recently, but people do not pay attention to like Canada exports natural gas as well, except that it does not dominate the news cycle. So the bias and fairness regarding the machine learning domain is about like, do you have too much attention on the dominant data points? And that's very important in a way that, just like a cancer, if you have a model diagnosing cancer, if you just diagnose everyone as cancer-free, then you get 99% precision, whereas, you get like extremely low recall. So bias and fairnesses can be understood and measured in a way of, precision, recall, and other, mean average precision or cumulative gain of your search results, etc. So those are like real world problems that need to be handled when you're building a RAG system. And also in the real world, the data can be very complicated as well. You can have a text saying that lion is the king of the jungle, and you can have two pictures of lions that are not similar to each other, and you have a voice that are explaining, this video. So there could be like multiple dimension of the information that needs to be handled and processed in a way so that we can do a more precise search and give a more precise answer. Given the time constraint, today there are a lot of things that we cannot expand on. And then we're going to have more advanced topics on teaching about RAG. There will be 4 classes in April, every Friday from April 4, April 11th, April 18th, and April 25th. So 4 classes talking about RAG in detail. We're going to do a hands-on projects to really get you grounded in the concepts and ideas that we talked about just now. We're also going to cover like more advanced topics, such as query expansion. You ask for certain things. You ask that, tell me about the elephant on the moon, and which should be expanded into 2 questions. Are you asking elephant on the moon in a scientific scenario, or are you asking about the elephant on the moon in a creative scenario? And then we can when we separate this with query expansion, then we can answer it separately, and then return the answer to the customers with answers for both. If you mean a scientific if you mean the question in a scientific setting, then I can tell you there is no elephant on the moon. But if you want it in a creative way, here is a story about the pink elephant whose name is Luna. So that would make the idea a lot better. Also, we talk about several search mechanisms today. And then, when we talk about several search mechanisms, you probably realize that why don't we have it all, right? There will be a combination of hybrid search, and there will be certain ways to do quantization in your vector database so that you come out, your vector database would provide you with the best search result. And then just now we talk about the multimodal search a little bit, so that you can not only search for text, you can also search for audio, video, and pictures, etc. Also, in a situation that, okay, I have this search RAG systems working. How do I know it's working well? There are several metrics regarding that. How do I know it's working well? And then also, there are certain things that you want to do the trade-off. Just now we talked a little bit about there are cost trade-off, there are answer relevance trade-off, there are how grounded your answer is trade-off. In certain situations, I do not mind to sacrifice sacrifice the accuracy of my results a little bit. Hallucination does not really hurt me from certain situations. In other situations, hallucination is a big no-no that I do not want any one of it, right? So these are all the design trade-off considerations that we're going to talk about in details. Okay, I think we come to the end of the presentation. So these are a few QR codes. I do conduct one-on-one training on machine learning for interview preparation or career guidance. This is a QR code for it. If you want to join our RAG courses in April, here is a QR code for it. And also please join our Mingdao AI LinkedIn group by scanning this QR code as well.